In this video, we're going to look at determining the empirical formula from experimental data. So if you have a sample of a pure compound, you know this is a pure compound, and you analyze it and find out that some part of it, either by mass or by percent, is calcium, and some part of it is chlorine, how can you go about finding the formula? And we're going to be focusing on the empirical formula, the lowest whole number ratio formula. And we're going to look at three typical kinds of problems. So here we have the problem we started with. We have mass of calcium and we have mass of chlorine, but that doesn't tell us the formula. We need to know the ratio of atoms of chlorine to atoms of calcium. What is that? Is it 1 to 1? Is it 1 to 2? What is that ratio? And we're going to start by taking the mass of each compound and converting that mass to moles. That is the first step. You're familiar with how to convert grams of a compound to moles. The next step is to divide all of the different kinds of moles of each compound by the one that is the smallest. Now, if you're using scientific notation, be really careful. Some people don't notice which is the smallest. So the smallest here is 0.0225, and that gives us here 1, and 0.045 moles of chlorine divided by 0.0225 gives us a 2. So that ratio of 1 calcium to 2 chlorines, when we write the empirical formula with calcium and chlorine in it, we get 1 calcium and 2 chlorides. So our empirical formula is CaCl2. And that looks like a correct formula for something we know as calcium chloride. And in the second example, we start with percent composition, the percentage that is sodium, the percentage that is chlorine, and the percentage that is oxygen. Now, if we have a 100-gram sample of this compound, a little more than 50% of it will be oxygen. So if it's a 100-gram sample, that'll be 52.2 grams. So we're just going to change the percentages to grams by saying 52.2% is 52.2 grams of oxygen. 29% is 29 grams of sodium, and 18.8 grams, I got those mixed up. That's 29 grams of chlorine and 18.8 grams of sodium. So we're just going to use those percentages as masses, and we're going to convert grams of sodium to moles of sodium, grams of chlorine to moles of chlorine, and grams of oxygen to moles of oxygen. So we're going to divide each of those by the smallest. So the smallest here looks like 0.818, and divide all of them by the smallest. And that gives us a ratio of 1 sodium. So in our compound, we're going to say 1 sodium, 1 chloride, and 3.26 divided by 8.18 is 4. So that gives us 4 oxygen in our compound. And that formula would make sense because here we have the sodium ion, and this looks like something called perchlorate. So sodium perchlorate, and that's certainly an acceptable formula. Determine the empirical formula of a compound made of 8.65 grams of iron and 3.72 grams of oxygen. So Maybe this person carried out an experiment and found these two values for grams of iron and grams of oxygen. But what is the mole ratio? What is the ratio of atoms of iron to atoms of oxygen? Well, we're going to divide both of these by the smallest, and the smallest is 0.155. That gives us a ratio of 1 iron divided by 0.155 is 1.5 oxygen. Well, here we have a ratio of 1 to 1.5. Now, we can't really write a formula, FeO 1.5. That does not make sense. We cannot write a formula like that. We have to have whole number ratios. Well, but we don't want to change this ratio of 1 to 1.5. We can't just simply say, well, it must be 1 to 2. Can't do that. Here's what we do. If we have a ratio of 1 to 1.5, we need to find a small whole number that we can multiply both of these by, so we'll keep the same proportion. So let's try to multiply both of these by 2. If we multiply both of these by 2, we're keeping the same proportion, but now we'll have a whole number ratio. The ratio will be 2 to 3. So in our formula of iron and oxygen, it'll be 2 irons for every 3 oxygen. And that makes sense. We would call that iron 3 oxide. So that's the empirical formula trick. Now there's one other thing I want to add here that a lot of people find helpful. A 4-step poem that a lot of people find helpful to guide them through calculating empirical formulas. Percent to mass, if you're given percentage composition, just change the unit to mass. Step 2, mass to moles. Convert the mass of each element to moles of that element. Step 3, divide by the small. And step 4, if you need to, multiply till whole. Percent to mass, mass to moles, divide by small, multiply till whole. And have fun.